All right, Sarah Savicool might watch this, huh? Say hi, Sarah.
Hi, Sarah.
Sarah, Larissa says that she would rather sit next to Anna Anderson than sit next to you. Interesting, she says that. Just keep that in mind. Okay, values for sine and cosecant. Sine is equal to 0 for certain values. We need to figure this out, okay? In order to graph secant and cosecant, which is our goal for today, we want to do this. We have to be able to graph sine and cosine. Why? Because cosecant is 1 over sine of theta, and secant is 1 over cosine of theta, right? That's the relationship. So we have to understand something about their inverse before we actually, or their reciprocal before we actually do this. So let's think about where sine is equal to 0. Let's see, what is the sine of 0? 0. So at 0, sine is equal to 0. So if I go, 0 degrees, it's 0. Do you know what sine is at pi over 2? It's equal to positive 1. Very good. And then at pi, it's equal to 0. At 3 pi over 2, it's equal to, very good. And at 2 pi, it's equal to 0. So you can kind of see what's going to happen here. At those spots, sine's equal to 0. Now, the reason why I'm interested about where sine is equal to 0 is this. What is the reciprocal of 0? Undefined. So these spots where sine is equal to 0 is where cosecant is undefined for x. And so those are the spots where we have what we call vertical asymptotes. Booyah, right? Does everybody understand that? If I take the reciprocal of 0, I get undefined. So those are important spots to know. How often does sine repeat itself? Pi, 2 pi, 3 pi, 4 pi. How often does it repeat itself? 2 pi. So if you look, sine's going to have a vertical asymptote at 0, at pi, and at 2 pi. Then at 3 pi and 4 pi. So I suppose there's, within one full period, you're going to have 3 spots where it's undefined. Okay? Where secant's undefined, or cosecant. Okay, cosine. Where's cosine equal to 0? Well, what's the cosine of 0? Come on, trig genius. Nope, cosine of 0 is 1. Cosine of pi over 2 is 0. They're all on your unit circle basic sheet, your graphic organizer that you got. It's all sitting right there. The more you can just remember it, the better off you'll be. Okay, so cosine is equal to 0 or at 1 or 0 at pi over 2. What's cosine of negative or of positive pi? Negative 1. What's the cosine of 3 pi over 2? 0. So we got 3 pi over 2, 5 pi over 2, so on and so forth. So secant is undefined for x values of pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. That is where we have what we call vertical asymptotes. Oh, one time I used 2 S's, one time I used 1. I don't know the correct spelling. I know that you can either say asymptote or asymptote. So maybe that's why, maybe I was thinking putting the emphasis on the first part, maybe. Kara didn't find me funny. Whatever. You're mad at me. Okay. Let's see. Basic graphs for cosecant and secant. Here's what you do. Okay, we're going to practice this. Instead of graphing y equals cosecant, I graph y equals sine. That's why I said you can't do these problems unless you learn how to graph sine and cosine. So we're going to start by graphing that. What's the amplitude? 1. What's the period? 2 pi, divided up into 4 places. Any horizontal shift or vertical shift? Nope. Where does sine start? 0, top or bottom? Zero. Starts here. Does it start by going up or down? Up. I don't actually draw sine because I want to draw cosecant. So I just draw a dotted graph. You sound really disappointed. Really disappointed. Now, here's the super important part that you got to think of today. First of all, you graph sine. Is there anything new about that? No. But we just said that wherever sine is equal to 0, or wherever it crosses the x-axis, what do I have? Vertical asymptotes. So you look at those spots where it crosses the x-axis. Are your vertical asymptotes. How do you like that? Don't like it? You haven't actually drawn any part of the graph yet, have you? It's all fake stuff. You want to draw the real stuff? All right, let's draw the real stuff. Watch what we did. We're just going to take each point. We're going to take the reciprocal of it, okay? So this spot is 0, right? What's the inverse of 0? Undefined. That's why I have an asymptote there. Look at this point right here. What's the height of the function right here? 1. What's the reciprocal of 1? 1. Good. If you have 1 over 1 and flip it upside down, we get 1 over 1. Be nice. All right. Okay, now watch this. This is where you're really going to understand. It's all going to come together right here. This is the last difficult understanding you're going to have of the day. Are you ready? Okay, I'm going to go to this point right here, and I'm going to move just to the left. If I move just to the left of this point, do I have a big value or a small value? Very, very small value. Okay, it has a height of like, this value right here. Okay, that has a height of like 1/20th, right? If I take 1 over 20 and I take the reciprocal of that, what do I get? 20 over 1. So that turns into a big value. So, and same thing on the other side. So your really little values, when you take reciprocals of them, they become big values. And so you end up with this kind of a shape. Some people didn't understand the first time I did it either, so we did another one. Let's try again. Watch. What is the height of my pen? 1. What's the reciprocal of 1? 1. What's the height of my pen right here? Yeah, or like a really small value, right? What's the reciprocal of a really small value? Really big value. And same thing over here. So you're going to end up with that shape. For the negatives, what's the reciprocal of -1? -1. What's the reciprocal of a really small value? A really big value. Beautiful. So wherever you have your, wherever sine reaches its maximum values or wherever it reaches its minimum values, we just put these U-shaped things onto there. And some people see these U-shaped things and they say, well, Mr. Gantz, those are parabolas. No, they're not. They look similar to parabolas, but they're definitely not parabolas. Because parabolas aren't limited in the domain that they can cover. These definitely are, okay? So they're very different. So let's do the same thing again with secant. Instead of graphing secant, what do I graph? Good, cosine. What's the amplitude of cosine? 1. What's period? 2 pi divided up into 4 spots. Oh, good question. Okay. See this right here? The red graph is the actual graph of cosecant. In order to generate those red graphs, I had to sketch sine, or the black and the green graph ahead of time. So that's the same thing we're going to do. In order to generate the red graph, we got to do the other ones. So you can't graph secant and cosecant without knowledge of what sine and cosine look like. And I'll show you something really cool after this, okay? It's cooler than you are. All right. Where does cosine start? Top, bottom, center. Top. Start by going down or up? Down, down, down. You know, I always get things stuck in my head, like, you know, when somebody says down, then I always think of the ants go marching one by one, hurrah, hurrah. And they all went marching down to the ground to get out of the rain. Boom, boom, boom. I don't know, we always just sing that growing up. The ants go marching one by one, hurrah, hurrah. The ants go marching one by one, hurrah, hurrah. Yeah, Sarah Savick will take that. The ants go marching one by one. The little one stopped to suck his thumb, and they all went marching down to the ground to get out of the rain. Boom. All right, so what do I draw next? The lines. And the lines go right through where cosine is equal to 0. We just look at the graph, see where it crosses, and we draw our vertical asymptotes. I have really nice lines. I hope you have nice lines too. Then I look for my maxes and my mins. And at my maxes and my mins, I draw my U-shapes. So I got one right here. I draw it. Got one right here. What do you think? Do you understand better now than you did 5 minutes ago? All right. So let's write it down for good measure. We're not going to do all these examples, but we're going to do a couple of them. Okay. So let's write down the steps so we commit it to memory. Instead of graphing y equals cosecant of x over 3, I'll graph y equals what? Sine of x over 3. Very good. That's what I'm going to graph instead. So the first steps for graphing secant, cosecant, sine and cosine. Graph corresponding sine or cosine graph. That's what you do. You have to start with that. If you want to graph a secant, cosecant graph, you got to sketch its reciprocal first. So let's look at that. What's the vertical shift? 0. What's the horizontal shift? What's the amplitude? What's period? Six pi. 2 pi divided by 1/3. Okay, so I mark it out. 1, -1, 6 pi, -6 pi. Divide into 4 spots. Where does sine start? Top, bottom, center. Centers. Is this one going to start by going up or going down? Up. So I start here. I go up, down, down, up. Actually, Regent, we could model a strum pattern because it's periodic by a sine or cosine function. Isaac? Strum. No, strum, like a guitar. All right. So now that I have that, I've done what I'm supposed to do. My second step will be to zeros and undefined. Draw vertical asymptotes. We'll use 1s through zeros, because that's where it's undefined. A lot of times people forget about that 0 spot right on the x-axis because there's, or the y-axis, because there's already a line there. Don't forget about it. It wants to be part of the group. Okay. What's my third step? Draw U-shapes at max and min. We're gonna think of that. Yeah. Watch this. I'm gonna graph it. The first one I'm gonna graph y equals sine of x divided by 3. Okay. So that will be this one in the center, and I'll even go over to my handy dandy thing here, and instead of that type of line, I'll make it a dotted line, just like it is. Cool. And then for this one, I'll make it bold, so that it really stands out. And instead of graphing sine of x over 3, I don't have a cosecant button, so I have to do 1 divided by sine of x over 3. So that's what you have to do if you want to graph this stuff. You have to do the inverse. And so let me set my window up. Looks like I got -6 pi. Looks like I've got a maximum positive 6 pi. I've got, look like a tick mark would be every 6 pi over 4, or 3 pi divided by 2. And my y maximum would be, or minimum would be like -2 and +2. And watch this come to life. Is that not what I have exactly on the board? How cool is that? Those two over there, they said they thought it was sweet. Okay? Or we're watching a movie, I'll bring the popcorn. The rest of them can starve. We're all going camping together. We'll have Dylan, well, him and his poor toenails. All right. Okay. So what? You think you can do this now? Let's try 2 harder examples, and then you can start your assignment. 2 harder examples, okay? We've been doing baby stuff so far. We'll forget about this one right here. Let's try -3 secant of 2x. Instead of graphing -3 secant of 2x, what should I graph instead? I want to graph negative 3 cosine of 2x. The inverse of it, so I can generate that shape. So, what's the vertical shift? None. Horizontal shift? None. What's the amplitude? 3, period. 2 pi divided by 2 is pi. Mark it out. The what? Oh, good question. So when I ask you to graph sine and cosine on your test, I want you to label all the tick marks. But when we do secant, cosecant, tangent, cotangent, there's just too much happening. I don't care if you write the tick marks for those, as long as I know what your period is. So you can tell by my graph here that the period's going to be pi, right? I don't care about all the tick marks. But for sine and cosine, I want you to do it. Okay, that will be our rule. Okay, so does this start top, bottom, center? Bottom. Does it start by going up or down? It's going to go up. Is that actually my graph? No. What do I draw next? What are they called? Can you have an asymptote ever in mathematics that's horizontal? Yes, you can. You've already done it this year. If you had to say y equals x over x minus 3, you have a horizontal asymptote equal to 1. So we have done that. So you can have horizontal ones. That has nothing to do with what we just did. I just thought you might want to know. I did my second step. What's my third step? Draw the U-shapes at the tops and at the bottoms. If you need to confirm it on your graphing calculator, you now know how to do that. But you are so confident due to your excellent learning provided by your teacher and your super duper smarts in your brain that you feel confident about it. Any questions on that example? Then we do the last example. Cross this one off. I don't want to do that one. We do y equals negative 2 cosecant of pi x minus 1 plus 2. Well, you know, you don't want me to pamper you the whole time, right? I mean, we need to. Okay, instead of graphing that function, what do I graph instead? Yep, so negative 2 sine of pi x minus 1 plus 2. That's what we want to graph. That will help us generate the graph of cosecant. So I must list all the important characteristics, starting with the vertical shift. 2. What's the amplitude? 2. Period. 2. It's kind of fun. And then the horizontal shift. 1 over pi. Good, which is about 0.3. All right. Now let's think about this. Okay. If the vertical shift is 2 and the amplitude is 2, how high will I have to go? 4. And that will just give me the top of the sine graph. That won't leave any room for the U-shapes, will it? So let's go all the way up to 6. So at least I have some room to do some of that stuff. So I'm applying my vertical shift right now of 2. vertical shift of 2. Period is 2, so I'm going to, this is a really wide graph. I don't know exactly why I did that, so call that 2. I'll break it up in a little bit smaller pieces here. Where's it going to start? -2 sine of pi x minus 1 plus 2. Does it start at center or top or bottom? Starts at the center. And so the center in this case is going to be 2. Hold on. Hold on. Hold on. Everybody pause. Just think about it. Normally at this point we draw a dashed graph, right? Before we apply the horizontal shift. Can you imagine having the vertical asymptotes and 2 dashed graphs on this sheet? If you got to do that, you got to do that. Let's take time and actually do the shift all in one here. What's my shift? 0.3. I'll show you. It's not that bad, though, because you guys practice this. So 0.3 is just short of a tick mark. So I'm going to take this first spot. I'm going to move it over 0.3. And does it go up or down? Down. So I'm going to go to the down spot here, and I'll move that over 0.3. Then it will come back up. Move that over 0.3. It will continue to go up. Move that over 0.3. Back down, over 0.3. Back down, over 0.3. Up, 0.3. So on and so forth. So I just saved myself some, some organizational space, I guess you could say. And then you can do it, with the so the back one would normally be all the way at the top. And I'm going to move that over 0.3. Middle, 0.3. Bottom, 0.3. Whoop! Messed that one up, didn't I? Don't go all the way down there. That's just silly. Everybody see how I generated that? Now here's the only difference. You don't put the undefined spots where it crosses the x-axis. You put it where it crosses the shifted axis. So U-shapes. There, I got it. So again, the only part of the actual graph is the red stuff, right? Everything else is just a help to actually draw the graph. You think it's really cool, right? You want to continue to learn it more and more. All right. Well, here's your assignment. It's on the board over there. I'll write it up here again for those who are on YouTube Nation. 5.4, page 451. Numbers 7 through 10, 16, 17, 37 through 40. That's it. Now, So this is Thursday, right? So we got Friday, Monday, Tuesday, Wednesday. What do you have on Wednesday? So you have Friday, Monday, and Tuesday to do then these three things. You can do homework. You have a worksheet that I handed out yesterday. I can hand it out to those of you who don't have it right now, and a study guide. And you have the whole time to work on any of those. The worksheet just summarizes, it asks you to do all of them. You know, sine, cosine, tangent, cotangent, secant, cosecant, so you can practice them all. The study guide, as you can see, is just a front and back page, right? That's it. The test, front and back page. That's it. But if you get one wrong, then you should have tried harder.